an audio. Well, good evening, everyone. Give us a few more minutes to join up, but we don't have nobody's join up, and half of you want East Coast time. So I guess we could maybe start, huh? How's everybody doing?
Good.
Good, good. I see. All right, it's about 6 o'clock something California, so it's a little bit after work time and dinner time, and I guess the Central and Eastern, it's already got to past dinner time, right? That's okay. Let's make something useful today, learn something useful. Let me share my screen as I was looking at it. So let's see. Oh no, this one is week 2. All right. So the week 2, what we have is let's look at the week 1. Week 1 there was a discussion due, and I hope everybody posted. I might have sent a couple of suggestions. No, not this class, the other class. Everybody has references. This is doctoral class. Level class. Okay, discussion was due Sunday, and if you did not have posts in grade yet, just go and add some posts. Better late than never. Get some grade for it to pass the class. I know students showing up every last session, every week for the class, but she didn't do her assignments. I don't think she had a passing grade, even passing grade. So do your assignments, please. I feel so bad for her. I can imagine how she was doing, like, oh my God, spending 2 months and not having anything to show for. All right. So, and the week 2, what are we having in a week 2? So it's about applied information technology and database management. And there's a professional assignment due. Oh, we can talk about it now, actually. To research industry, and then explain how they convert to telecommuting. So basically, how they went from office to work from office to work from home. It's very interesting because I was working from home as a computer programmer for like 30 years. And when I asked them, hey, can I work from home? Everybody was saying, no, 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 we need you in office. We need you in office because of block communication, design sessions. But still, I was finding jobs to work from home. So it's all right. But 80, 90% job interviews, no, 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 we need you in office. We need you in office. We need you in office. And suddenly, there was a COVID. And guess what? Everybody's working from home. Suddenly, we don't need you in office anymore. We can work from home. Everybody can work from home. Yeah, you guess how hard I was laughing on it. Like, not on COVID, but the change, the shift from working from offices to working from home. Yeah, it can be done. But, there are issues, security, equipment. All right. So a little assignment about transition, working from office, working home, working half-half, hybrid. So like management issues. Let's say you're a director of information systems or chief technical officers, and you have to make sure that company has 500 people. What do? What kind of systems you give them? It's your job to think of it, not theirs. What do they need? You need to think of what they need. Your boss is going to ask you, how can we do that? Right? What kind of policies or procedures or security issues you can think of you need, right? Being your job, you be in charge, you writing up policies, how the company of, I don't know, 500 people is going to work. Because I work a company of 100 people, and I've seen how that works when um, database doesn't work. I don't know, database log, something happened, database log, and they cannot restore, and suddenly there's hour or 2 hours, 500 people doing nothing. Yeah, my boss, chief technical officers, was not very happy about it. But I gave him advice what to do. He didn't want to follow my advice. So I let him cook for about 2 hours and said, "Boss, how about I help you do what I suggested?" So then I went and fixed his database after having him 2 hours cook. So, and then everybody went back to work. So next time he listened to my advice. Just something from my work history that this is actually important. The policies, procedures being in place, being written up, being followed is important. So my thought was we just touch upon chapter 4 and 8 to some practicals, and this is a doctoral level course, so less case study and more of a research, I would say. So let me see what I think is important in this paralegal. I mean, they do have a slides on it, but there are too many slides and not big fan of their slides. What does it say? What is it? Chapter 4, chapter 8. I think there are way too many slides on this. This is just the basics what an IT is, and I think this is introductory chapter, information technology, so I won't spend too much time. Just information technology definition. Here you go. Computing systems that can enable, what does it say, usable organization and to enable facilitates activities. Basically, computational systems that could be clay tablet. You know, in old Egypt, clay tablet was information technology. Yeah, it has information. They can write how many grains they had in a storage. So clay tablet or papyrus. Computers today, I don't know what's going to happen. Quantum computers or AI in the future that's going to help organization or, could be company, could be, who was it? King of Egypt counting grains in a storage on a clay tablets. Same thing, in my opinion. Won't go into basics, input, output, software procedures, also components. So half of your IT profession background, other half is business background. I think all of you have a basics understanding of IT. So we're gonna go into that input devices. That's obsolete. There are no input devices. Well, there are today, but in the future it's gonna be all voice. Well, we need input devices to type prompt to ChatGPT until we start doing with voice, as you showed us last time. Just speak with your browser and it's gonna do for you. Same thing. So this is that bit old content. Processing. So information systems have three components essentially. Input, something gets in. Processing, something gets processed in some way, and then it gets output. We get something out of it. That's it. So, and there are various input devices, keyboards, mouses, tablets, voice, vision, iris scan devices, fingers, print scan devices, all kind of whatever it is. Um, it could be voice, information systems. We can be yelling from the hill to hill, "Hey, how many sheep you have there? We have five. Okay, write five. Okay." It's like in a herd information processing. We're counting our sheep from hill to hill. It doesn't have to be computers. Nobody said it has to be computers. Never think it's just to be, always has to be computers. The information systems have been around for like thousands of years, in my opinion. And output. Oh, okay. Well, this is, or output can be a fraud detection system. Like, okay, this person is conducting fraud as a criminal, or we don't have enough grains in the storages, or whatever our reporting systems. There has to be some kind of reporting system. As a programmers, we used to have in a tabular forms report, but chat output can be full book written out by chat GPT. Hey, write me a book about something it can do, or write me a video, make a video about like cats, like humanized cats. My mother watches those humanized cats. I said, Mom, these are all artificial intelligence, those human cats feeding kitties, like sitting on a table. That's output, video, fantasy. All right. Uh, Programming languages. And we used to learn programming languages in computer science schools. And what are the people going to learn, students in the computer science schools in the future? I don't know. It's very interesting. I remember I had a course. It's called Languages of Artificial Intelligence. What we thought at that time would be languages, program languages, to be what they call Lisp and Prolog. So when I went to college, I learned how to program Lisp and Prolog. These are languages used for decision trees, decisioning systems. What was considered artificial intelligence, I don't know, 30 something, 5 years ago. Um, okay, so this is important. So there's some kind of data storage system. Does it has to be computer? How about this writing here? You know, paper files, so data storage system before computers. It worked fine. I mean, 15th, 16th century merchants created double accounting systems, right? Merchants in Venice, Italy, they invented double accounting system, double entry accounting system. And for you from business majors, know what is. And if you didn't have it, of course, bookkeeping, accounting, then it's like, debts and liabilities, double entry. So assets and liabilities. That's what being used for all of the accountants around the world today. They don't have computers. They just had a piece of paper and like abacus and little beads and something. But they have a modern computer-based databases. Futures, I don't know. So these are some examples. Reporting software, what else there are? So these are groups of software systems or packages that are important workgroup software, like sharing, like Zoom, there are versions of that, like social people connecting software, something in various forms, like Microsoft Teams or Zoom or Google Sheets or something. There are various versions of it. What do you think here? Systems, well, that's pretty standard. Microsoft Windows, Mac OS, whatever it is, networks, internet. That was very up to date 20 years ago. Network protocols. Most people, well, computer engineers know lots about network protocols, but it's becoming obsolete. Science is simplified. I remember studying that a while ago, long time ago. So networking is old news today. Networking topologies, how the networks have been wired together, how physical wires have been, everything on one wire, for example. That's old news, 30-year-old news. Star topology, everything is being plugged into what we do at home. So you have like an internet router, everything's being connected through your Wi-Fi. Today it's Wi-Fi. Actually, I have a plug-in. I like cable internet. I'm old-fashioned. So every home we have like a Wi-Fi router that all devices connect to. That would be like example star topology. Ring topology is a little bit more obsolete, but that's something IBM used to have ages ago. And various other combinations of wire. It's just obsolete. Won't get in it. Oh, so here's some architecture that was prevalent around here for the last 20 years. Used to be 30 years client server networks since 1990s, 1985, since we had personal computers come up, IBM personal computers compatible, so clones. So let's have my little computer here local and it retrieves data from a bigger computer, central computer, and that's how it worked 30 years until those computers got moved to cloud. But still version. Cloud servers has version of client server networks, except servers are not boxes in a office backroom somewhere, but they're somewhere in the cloud. Amazon or whatever it is. And my computer is personal, still connects to cloud in some way, either with data or web browser, different technologies. And ancient types of servers. So what to care about is that computers can be specialized and more specialized. I mean, it's just a plain same computer, but it has separate function in most companies, organizations, either the physical computers, a virtual cloud computer, for example, and because they have a separate functions. Oh, this computer, why? Because there was like limit on resources one computer can do. Although today with on-demand Amazon computing power, that's becoming obsolete, having to specialize the one physical machine to do one thing only. So let's say it's going to be our print server. And print server, they have to render graphics for the jobs. That was very consuming. So this is going to be a print server, and we're going to have our two, three printers hooked up to it. So hardware issues. So database server, you're going to buy a big fat machine and it's going to run database, and data queries can be very intensive. I've seen them run 30 minutes. So bigger the machine, faster they are, and users waiting 30 minutes, literally, sitting here doing nothing, being paid an hourly or salary doing nothing, waiting for a big fat machine to spend 30 minutes doing report. I've seen that. A network server would be more like one machine where everybody connects to. Let's say if we are remote and then we from home we connect usually to network server that controls security. So they're more like dedicated to do security checks, authentication. Okay, so I connect to that security server, then I pass my clearances that I can connect everything that's behind it, so database servers and or application servers that have some kind of special applications. And that's about it. Won't go too much into it. Let's look at the chapter 8 and do the practical. And chapter 8 is one more of a specialized out of it. This service. So So I picked up this database server and goes more in detail on database management, I would say. So what do I think is important here? Well, there's way more data, so we know that every click is being recorded on Facebook, and that's all right. So as the managers, let's say you graduate, you got the job as the manager of IT. So part of the job would be to manage corporate information. So you need to store it somewhere and you need to manage the access to it. How about practical? What would be the job of it? Let's see. So we need to control access. Who can access which kind of data? Executives can see everything. And now why doing that? Espionage, corporate espionage, data leakage. I think I was looking the other class. There was a information security issues. I think there was a 2.7 billion data records leaked national public database. I think that was the, let me look at it. Mm. Which course was that? That was the other course. Let's look it up. Let me share the article with you. This one, MIS 500. And week 2. So data breaches. World's largest data breaches. Let me share this with you. Here, 2024, Ticketmaster, national public data, 2.7 billion. Indonesian health agency, Indonesian SIM cards, Facebook, 500 million records, phone names, locations, emails, Shanghai police, unbelievable police database stolen. What else we have? Indonesian SIM cards, again, Facebook, 1.1. Aadhaar, this is Indian database, right? Biometric database. 1 billion records. Marriott. So, Equifax. All of US citizens in Equifax are here, 140 million US people. But this one, there you go, national public data. 2.7 billion records, US citizen, Canadians, United Kingdom, everything. There's no privacy. So, if you're a boss, do you want to be responsible for a breach like that from your database? I don't think it will look too good on your resume. Here's a little bit of history. Database used to be as a part of a file-based data storage, in a files before we had these other types of databases. Yeah, I remember doing that. When I was a high school kid, I wrote a phone book, search directory. All data was in one file, big one fat file. You just have a key and a data. That's it. It took a while to work on it, but it's doable. That was my high school assignment. Something, write a phone book directory. You can add person to phone book. You can go search by name and you can delete, edit. It's okay. It's a file-based data storage. Everything in one file, like an Excel sheet. That's it. And then we get a little bit more sophisticated. What is it? I've got the benefits of database storages. But here you have database management systems, modern, a little faster, that do have built-in security. You can have a structured data. And today there are different types of structures. Database, we have our relational databases, we have our object databases, we have a graph database. In different ways the data is organized, connected inside. And it's good for different purposes, I would say. This was something about designing databases. How do we design databases? Traditionally, we would make what's called entity relationship diagrams, ERDs. So part of you who are engineers, you've seen it, you've done it, and other half your business side. This is a quick intro into database design. So we start designing database in a program, in a software that's like allows me drawing those databases on a sheet of paper, which I have a special program to do that, and I would print it, plot it. And I used to have a big plotter, like, huge, like 2 or 3 feet, I believe, to print those diagrams, to plot them diagrams. And essentially it is how the data is connected. Diagrams say, okay, how is our data connected inside? Although this is more for relational databases. Today, databases like document database, graph databases, to use different types of diagrams and design. So I'm going to design here. So this is about design your relational database. That's about 10, 15, 20 years old theory. I don't know if you have an exam on it, but you can study up in your course book. How do we design databases? Which I think okay. What is important is here is what I think is important here is the primary key. So here's an example here. So in relational databases, we save the data in the tables. In a document-oriented databases, it's so called document, but still there are these pieces of data. Somehow they have to fit in. They have to get there. So here's a book, let's say book number 1, number 2. These are books, and these are more details about it. Who purchased it? What was the price? Something. Let's say somebody purchased book number 1 here. Somebody purchased book number 1 again. Somebody purchased book number 2. These are about purchases. Here's a concept of the keys, primary keys. Primary keys is the way of uniquely identifying piece of data. So whatever database technology or model or version or designer, somehow we need to know, hey, you are you, and me is me. Because what happens if we mix up our checking accounts? I don't know. Your money ends up in my checking account. That's better than my money end up in your checking account, right? Or for me. You have different opinion, but so we need to, or your money end up in somebody else's account. That won't be too good, right? So we need to way to uniquely identify every piece of data in a database, a person or entity or whoever it is, checking account. That's all that's what primary key is. That's it. And let's see, what is one example of database design? If you've never seen it, it's more like it's called logical database design. It is how the data is connected, information. Basically, how's information? What connects to what? Who connects to who? This example of the books and library. Okay, library has the books. There are several copies of the book. Maybe they have 3 copies of the same book. There are members of a library, public library, let's say, or university library, and then you borrow the book. You get the book from library, and library keeps a track which books you have and which books you don't. You have to return. So this is one example. So first we do the logical design, and this is like a long process, hard process, I have to say. And I use that drawing diagrams to help with that. I print them, I take them to client, I ask them questions, then I write on paper, then I come back and then I redo them, then I print them again. It's, I don't know, slow process. And then from the logical design, what's called, we go to the physical design. Physical design relates to the database we have. And our company might have, organization might have a Microsoft SQL Server, we might have Oracle, we have Postgres or MySQL, whatever different product we have. So this data from concept has to get into the real physical storage. And that's where we get into physical design, and different manufacturers have a slightly different standards. See, they have a different, for example, what are the integers, what are numbers, MySQL, Access, SQL, Oracle. They're similar, but not all the same. And it keeps database designers, programmers in job for now. And we won't get into the database programmers jobs. Okay, well, this is a quick intro in database design, and this is, I did teach course on database design like 8 weeks, and the next course I did teach was the SQL programming 8 weeks. So I'll just give you quick points for you computer programmers. You know how to do that already, and for non-programmers, you're probably never going to write SQL in your life, especially with AI here. So I'm going to go into the programming with SQL. I don't think there's no. Do you have exam in a course or quiz or something? I don't think you have one. Okay, so this is more about the database SQL programming, which I won't go into it, but you care about it. But security, yeah. So okay, so security issues always important because we have these billions of data leaked. Could be mine, could be yours. My credit cards, I keep closing them, opening new ones sometimes. So that part of the legal, ethical issues. Uh, I think I'm okay with that. It's already. These are just things that I think are important out of these chapters and are still somewhat relevant to today's date. This book was written up uh, 2011, so 10, 14 years ago. So for like 2011, this was important, but 10 years later, that's many of that changed. All right, so let me stop sharing this. Any questions about this or any comments? And what's your experience? Any database programmers, designers? Anybody makes databases? I am. I'm just checking how many database programmers we have here. No?
I just use SQL sometimes. So
Okay.
it's not a programmer, it's just someone who writes queries. So
Okay. All right. So there's some knowledge there how to do that.
I have had some experience with MySQL.
Okay. So we
Yeah.
have two SQL programmers. Anybody else? Third of the class? Quarter of the class? No. Okay. Well, we learn how to do that and we'll find out, do we really have to be doing that? Do we have to be learning how to do it? Is it relevant? It is for now with systems we have to keep them in running, but we'll see for the future. So I have some practicals that came after the book, and I'm looking at them and I say, I did teach course that year ago. And it's like, these are practicals for the master's level students to practice this obsolete. And you, as a doctors, futures doctors of business, I think you should be more focused on the research, what's today's and tomorrow's technology. So we'll do case study and we do research case study and we do similar as the previous one. Because there's this thing that's called AI. I used to keep saying, AI is coming, AI is coming, AI is coming. And one student correct me, no, professor, AI is already here. They're like, what? Wait, hold on. Yeah, you're right, AI is already here. In my head, AI was coming. And student says, no, no, professor, AI is here. So let's do practical. All right, so I had one written up. And let me see. Let me go back to I have them in the text files, week 3. And I think we have time to do one practical very well instead of doing two small ones. No, that's week 2 practical. Week 2 practical 3. Let me post it to your gap. Where is the gap? Announcement, Tech 81, announcements. Yeah, I think this should be good. Practical. Let's just do one practical. There's not enough time. If we do one good one. All right. So let's do this. We share with you. Okay. I mean, coursebook has a case about database management, use technology. I don't know. It's yesterday's news. Future. What's future bringing? What's the day in future? What's your research going to be about? So There's this thing AI in everything, including database management, meaning data management, data security, database programming. I don't know. I don't know myself what are all possible uses. So let's go out and find out what are some preferably published peer-reviewed academic articles, not necessarily just newspaper articles. But these are easy. These are for master students, your doctoral students. Find some published research articles, peer-reviewed, and just, I know it's a dense, it takes time to read. Look through it, summary, couple of points and summarize it, share with us. Let's maybe have 2-3 groups. Maybe we can, like last time, learn about 3 articles, peer-reviewed articles, and build a library of AI use in various IT branches or groups or uses somehow. I don't know. Might find your doctoral thesis one day somewhere in it. All right, so let's do, how many students have? Maybe 3, and how many students in classroom? 1? Okay, how many? 2, 3, 6, 8, 9. So let's do maybe like three groups of 3. How about that? And I have, where's the announcements? Where's the breakout rooms? Well, here's the breakout rooms. Let's do 3 rooms, and then it's gonna take time. Take your time, serious research. It might be time for breaks. We might have to time break while you're just on it. That's okay. Or keep working on it. You don't have to take long breaks. We can end up early. Okay, so let's do three rooms, 3 breakout rooms by 3 people. And in classroom, you can just dial in into the Zoom maybe to join your group. She can just dial in. Oh, I didn't click open. Sorry. There you go. Let's see. Assign to room 2. I don't know. It's assigned to room 1. There you go. So I'm gonna mute it.
Hello, Professor. Can you please join me back to my room because I was locked out?
Can you hear me? Yeah, I cannot hear you. Can you add me to the group?
Which room you? Were
Sorry.
you in one group or were you within a group?
Oh, I was not a part of the group. So yeah, can you add me again?
Okay. So let me add you in. Let's say
Yeah.
The professor,
Uh-huh.
our group is done.
You were done? Okay. Let's take a break. 10, 15 minutes break and then we'll review. I see you coming back from a room. Okay, right. Okay, so they're done. Let me move you to another room. Here. All right. So I seen you're done. You're coming back. Okay, take a break. 10, 15 minutes, especially in the classroom. We're at home, so we have a little more freedom. All right. So breakout rooms are closed. I did send messages, if you're in the break, take a break. But otherwise, let's see what you found out. What can you show us? What's future bringing?
Group one or like room one can go first, Professor.
Go ahead.
Okay. I have posted the link that our group picked in the chat.
Okay. You share your screen with us and maybe just walk us through it.
For some reason, I'm not able to see the, oh, there it is. Sorry about that. Okay. Do you see it? Okay. The article that we choose is The Impact of Modern AI in Metadata Management. This is a recent article published in July of 2025. So the article basically explores how modern AI technologies are transforming metadata management. And when we think about metadata, it is data about the data. So basically, metadata has the information that tells us what data means, where it comes from, how it's structured, and how it should be used. So when we think about metadata management, it helps database with things like data discovery, governance, quality control, and integration. So without a good metadata, even high quality data becomes very hard to use. Especially this is the case for large organization. And I'd like to show you a metadata life cycle. Okay. So here they also explain the 4 steps of metadata lifecycle, which is the data acquisition. How do you get it? How do you clean it? The next step is cleaning. The next one is verification and the continued maintenance. So the authors start by explaining that as databases grow larger and more complex, managing this type of metadata is difficult. Okay. They also explain about the traditional process, where it's mostly manual, and then you use rule-based systems where human define the schemas, the tags and classifications, which is very difficult. And sometimes the problem is that the process is very slow and there's a lot of errors that can come up and it's not very flexible. And this is for a less volume of data. When we think about data that's huge and as data is growing, there should be different methods, and traditional methods struggle to keep up with the growing amount of data. In this article, they also explained about the AI-driven, this is the traditional one. So they also explain about the AI-driven methods like machine learning and natural language processing that can automate any metadata task, which my teammate will explain.
Okay, so the paper proposed a conceptual AI-powered framework for managing metadata in modern large-scale data environments. So this framework is designed to be scalable, interoperable, and secure, which allows the organizations to manage rapidly growing and diverse data sets while maintaining compliance and trust. So in overall, this framework includes 3 major functional layers. The first layer is automated metadata management. So the AI will automatically generate, classifies, and enriches metadata and support large-scale cross-platform datasets. The second layer is quality assurance and governance, which ensures metadata accuracy, compliance, and auditability. and tracks metadata history for accountability and trust. So the third layer is analytics and accessibility, which use advanced analytics and visualization to identify patterns and trends and enables intuitive querying and interaction with metadata. So this framework enables organizations to manage high volume, high variety, and fast changing data sets. And it also provides a blueprint for building next generation metadata platforms. So my teammate will talk about the outlook of this framework.
Okay, when we look at modern metadata systems, the biggest challenge is how fast and complex data is growing. Traditional methods just can't keep up anymore, so AI becomes really important. AI helps metadata systems learn continuously, operate themselves automatically, and work across cloud and edge environments, so data can be processed faster. It also improves accuracy by generating and enriching metadata without heavy manual work. Overall, AI-assisted metadata makes it easier for organizers to manage data better and prepare for future data challenges. Yes. I think we are done, Professor.
Interesting future directions. So where is the future and where is that going into? So now they use AI to help with classify metadata, which, well, yeah, used to be a very manual process. For example, give me my example. So when I wrote in doctoral dissertation, asked them how many references I need to have. And they say at least 50. Oh, wow. So now I'm having 50 or 60 references, so I need to know about each one. I had them printed out. I had the notes written up on each one. What's it about? I mean, what information can I use of it? And it's definitely a slow and manual process. You know, you mentioned it's slow. Yeah, it was slow. But AI can maybe summarize this. Yeah, you know, here's what they say. This is what's about, and this is what's useful. Oh, okay. And there are emerging trends. So where are directions for future research? How about the last one? LLM is agent, and what is that? LLM is agent framework, LangChain, hooking GPT, tape agents, and agent square. These are four words
So
that.
yeah, so it says in metadata system, these agents can carry out tasks like schema mapping, formal conversion, metadata validation. I think it's individual tools or or how they refer to as frameworks in here, and they are using it for automating the metadata validation process and other consistency checks with like limited human supervision.
Right. That means we can get the forms. We have people, 500 people processing forms, but we get forms and upload to ChatGPT. Doesn't know what to do with it. But what is this? Hugging GPT might be add on to GPT and to process forms that organizes, I don't know, the car loan. I have a car loan applications or whatever a company does. The people looking at it and actuaries looking at it. This is metadata, yeah. My car loan, I did a car loan refinance. That's information. It's a metadata. What's application form? And for now, we have the people eyes look at. I don't know if ChatGPT does that now.
So one news I saw in the recent weeks is that ChatGPT is going to buy Pinterest. Pinterest is basically, it has a lot of image catch. So they're going to buy it and train it for digital marketing purposes. And they're going to use that for ChatGPT's training. And then that is, if they do that, already Pinterest has a lot of ads targeted upon your search. Like if you search for crabs or anything, they suggest all the items in that. But if ChatGPT goes ahead and buys it, they're going to like understand the behavior, like our consumer behavior and everything, and they're going to like change it very much. But that's a recent news. And this year, ChatGPT CEO is going to buy Pinterest.
Interesting.
Mhm.
Same thing. The images are okay. What's the image about? It's metadata. Yeah. Uh-huh. Somebody mentioned something, interrupted you. So you're saying ChatGPT is going to become the largest marketing company in the world then?
Sounds like it. It's Google Gemini, ChatGPT, there's Grok. There's so many AI tools coming out each day as we speak. There's one for realtors, there's one for students. There's so many AI tools. I think the key challenge will be to identify which is authentic and which is not, like selling your data. So
Pinterest owns lots of images, so it's about
yep,
copyright, right? So they can own it, and then based on those, they can make what's called derivative work. Okay, so they can use that, and ChatGPT can generate new images. It's a
yep,
problem. If they feed ChatGPT with images and generate new images, problem is copyright. It's like $1 billion lawsuit or more, 10 billion. But if they say, no, 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 we own the library of, I don't know how many images is the Pinterest, but we own that, it's a derivative work, and they say, hey, ChatGPT, make me image based on whatever we own in Pinterest. And they say, okay. Now they have a zero problem with copyrights.
yep.
Right? Because I think there's a lawsuit, somebody trained ChatGPT with public information and for private purposes. I heard there's a lawsuit about it, said, hey, you can't just use public information or private or somebody's private, whatever they use to train it. There's a lawsuit about intellectual property on it. They say, no, that wasn't okay. Interesting. All right. Well, thank you for sharing that with us.
Yeah.
All right. How about group 2? What do you think?
Yeah, thank you, Professor. We want to talk about a open source technology that is named Anna. This open source technology, while it's a REST server in Python and Flask, it augments existing database capabilities. The database we're talking about, oh, sorry, I haven't shared my screen. The
Share the screen.
Sorry, can you see my screen?
Mhm.
Yeah, sorry.
Yeah.
Okay, so the database we're talking about is electronic health records databases specific to animal health, veterinary health record databases. We refer to them as EHRs in this paper. What Anna, the open source platform, does is it integrates all sorts of popular machine learning classifiers and tooling that are used to perform predictive analysis on data directly on the back end into the electronic health record. So normally, if a hospital or if a veterinary hospital wanted to create a capability for predictive diagnosis of a particular animal's health condition, they would have to code up a lot of specific tooling and then integrate it on top or make it an application that someone has to then access with a separate access code, separate user ID and password. All of that is taken away with just augmenting the capabilities of this database, of the health records database with Anna. Anna will perform the backend prediction and share that information directly in the health records. So that's a very quick overview. I'll let my teammate hop into elaborating a little bit.
Thanks, Jay.
Yep.
So basically, in this whole paper, there are like an example which is given where it says that whenever there is it actually predicts the disease. As an example, in dogs, so there are like 3 ML classifiers that was mentioned, and the thing that stands out in this paper is like they have like a real deployments. It's not like a simulation. So an actual clinician can actually use this workflow to predict the disease, and it also like demonstrate like AI handling live. It's kind of like heterogeneous data from the structured database, and it shows like a middleware approach, like it's work like AI can be added on the top of that existing model rather than redesigning the whole database system. So it is in there are some implication that mentioned was like its scalability and flexible since it supports like multiple models, language, and data types, and also it has a potential of a cross domain potential where like framework could be applied to finance or logistic or any domain that requires like real time predictive insights. There are a few things which is mentioned as a future reference, like it's not in particular section, it's like at the end regarding the results. So what it says, like in the future scope, it mentions like if and it is extended to like support multiple EHR systems with different database structures, then it can just improve like real time performance by reducing the latencies. And also, if is a future reference, it says that to add automated model monitoring just to track like prediction of accuracy over time. So yeah, that's pretty much what it explain about this article.
Yeah, in the real world, generally with a lot of these electronic health records, they're generally developed in-house. Some of these were developed in the late 90s, early 2000s, or even earlier, right? So again, there is no roadmap for like constant reinvention of those databases. You just cannot because they're in production. So tools like this are pretty crucial because they just cannot, beta test a new software product, and then that just causes a lot of friction. So we thought this was a great example of just augmenting capabilities with, modern technology, modern AI capabilities.
Share just the diagram, that there was this diagram.
Yeah. So this was the architectural diagram.
No, that one, where was it?
Sorry, this one. Yeah. Let's see. Full site.
So Anna server, so that every hospital has it, or has been hosted outside, outsourced.
So the EHR is in this particular case, this is in UC Davis Veterinary Hospital. So this electronic health records database was created in-house. It's a MySQL database. So Anna is hosted, it's a Python REST server. It's hosted on a virtual machine probably in the same rack, we're not sure. Since they're hosting the separate classifiers on Apache web hosting. So I think it's a Apache web server on which the VM is hosted, even though it's a Python REST server. So that way they're just using existing infrastructure. They're using limited IT resources, limited engineering our resources, and you don't have to hire like a whole team or get a consultant team to do all of this. You can probably just contract an independent contractor to work on this for like 6 months, implement
I
it.
see.
Yeah. And then
So this is okay. So this that dotted dash line says on a virtual machine. So that's probably one computer, one machine, virtual machine. It could be
this is Windows 2019 apparently, from what I see.
yeah,
but the other ones are hosted on Apache web hosting.
Well, they have a one machine that can be in the cloud somewhere, Amazon, whatever. That's a virtual machine, and they can run Apache server. That's okay. You can run Apache server on Windows.
Okay, I don't know. Yeah, I keep forgetting.
Yeah, we can run. So this is like Windows 2019. It's running Apache server. I remember installing and playing with it. So they have a one Apache server, and it's running on a server, which they configured to talk to those databases wherever they are, inside, outside, MySQL or something. And then what's more than installation and configuration than programming.
Yeah.
So install on a server, configure it to talk to the databases, hematology, and the others, and then install Apache server, Flask, and then install these separate Addison server, Laptop server, Shunt server, whatever they are. And they are on local DNS. You can see 127.0.0.1. That means the same machine. They're just talking on a different ports, 5001, 2, and 3. So they're like three separate servers, four separate servers running on the same Windows computer, talking to each other, which is just configuration, and it's all like open source probe. I don't know what that is, shunt servers. I never said.
So these are specifically just classifiers to predict a specific condition, a medical condition. Leptospirosis is a lepto server. So that's what
these
we
are like
understand.
open source.
Some of these are. The Addison server is based on MATLAB based classifiers. So some of the others is just open
Python.
source.
Yeah, if that's a Python, then Flask, Apache, that's open source. Doesn't require really anything. So at least two of them. MATLAB runtime, but okay. Runtime, I don't know what's licensing for MATLAB runtime. So this would be very cheap, basically setup. Configuration, and maybe you say you got consultant to configure it and keep it running. You don't need to have like a full-time IT person. For small veterinary hospitals, they don't have. They just have a receptionist and veterinarians, and they cannot really afford. Maybe they can have somebody, 4 hours a week, kind of monitor these, administer something, half a day or day or something like that. Interesting. I never heard of it on a server, but see, this is, and where is the, okay, so it integrates, UC Davis. So integrates machine learning classifiers. Okay, machine learning is part of AI. Okay,
so they're trying to predict specific health conditions in animals. So each of these classifiers will assign a score to a particular, animal profile that is in the hospital, right? So it'll speed up diagnosis. It'll speed up, all the processes that are required. Like it just makes things so much more efficient. You don't need whole new tool. You don't need a subscription, nothing.
So there are like three of them, and if three of them agree, then it's high chance probabilities happening or something, or at least 2 to 1. So
I think each assigns a different score for a different disease, probably. Yeah. Is that right, Solomon?
Yeah. So basically, NI is kind of like a standalone backend server, and that is like separated from like that EHR system. And that server will be handling all the data request and pre-processing and communication with this ML models.
Yeah, so it's kind of separating, decoupling database from, this is like a like processing server, something like that.
Yeah, and it's very privacy friendly as well because it does not transport identifiable information, doesn't do anything else except it takes the prediction scores and then stores it on the specific animal profile or the specific profile for each entry in the database. Like it performs the analysis and just gives the scores into the EHR. So there is no, it's doing minimal database retrieval so that privacy is taken care of.
Yeah, so these are steps. It says circle, say number 5 and number 6. So it's kind of returning some kind of analysis to the 5 database, and then at 6. Number 5, pastes to your chart, expand users, and store class results, timestamps, MySQL, establish performance. Okay, so all right. So basically just needs number 5. Number 6 is for development of classifier for quality control to see if they agree or don't agree. Number 6, I don't see to be really necessary for the users. User doesn't care. Number 6 is for software developers.
Yeah.
Very interesting. Okay, see what people do. I guess we learned something today. I did learn something today. Very good. Thank you. Okay. How about group number 3? Room number 2. Who do we have there? What did you come up with? Do you have anything for us?
Yes, where is he? You added somebody late to our group?
Right.
Yeah, he's gonna present. We made just a little three-page little PowerPoint.
All right.
Yeah.
And post us a link in a chat for this previous, Anna. Did you? Oh, you did. Okay. I'll put them together, put them in the announcements as a weekly recap.
Okay. Sorry, I was supposed to present on our group's behalf, so. Can I go, Seetal?
You show the PowerPoint?
I will start.
Oh, okay.
So we discussed about the self-driving database management system. Since there is a lot of increment in the data, it is harder for the for the human to make the management. So with the help of the AI, there is a greater advantage in terms of management, maintenance, timeline, security, and user interface. Like in maintenance, because manual tuning is not necessary. There is a self-tuning and autonomous operation. AI has a lot of greater advantage, as well as in the timeline in the traditional system. Just because error are fixed only after they occur. But with the AI, it is a proactive means there can be a predict and prevent system. As well as in terms of security, the traditional is a static and rule-based monitoring, and with the new proposed architecture, it is more adaptive and it can find the anomaly and detect it and like prevent it from occurring. And in terms of user interface, traditional use the SQL system, whereas with the AI, we can use the natural language for the query purposes, and that makes like non technical person who do not have the query skill also take the advantage of the database management system. And further explanation is my team will join. Okay, I can go for the other also.
It's all right. Go ahead.
There is a
One
advantage in
second.
terms of the
1 second.
operational and the organizational.
Hey, we made a PowerPoint. Can you present the PowerPoint?
Yeah, we have the PowerPoint as well, but let me share the PowerPoint.
PowerPoint is good. Original article is fine too. But let's see.
Yeah,
We
the
can show
PowerPoint
both.
was it was just simplistic. That's all. Yeah.
Yeah, I talk about why AI is like advantage over the traditional system, and for the benefit part, there is a business benefit because there is low operation cost, and it also reduce the dependency upon the export administrators. It have the improved system reliability and make it more faster. And the future direction, uh, the AI-enabled database represent a critical shift toward the autonomous, scalable, and the intelligent data infrastructure that will shape enterprise information system. And this also help to shape the advanced analytic, business intelligence, and real-time decision-making capabilities.
Interesting. So, okay. Show us back that original article. Let's go to article. Let's do. This was interesting. Okay. Share that article with us. Okay, good. Good. This PowerPoint is good. Gives us like quick overview of benefits instead of going through that. These guys have a more of these diagrams. Okay, so let's see. So the diagrams, runtime architecture, workload modeling, control framework. So they say, I was reading it. They say all databases are too complicated to just add something as an add-on. And then so database management systems was introduced to simplify programming. And they're right. I agree with them. You just have to write
Yeah.
query that you like, right?
Yeah, because of the AI, like we can use the natural language for the query, and that makes the work a lot simpler.
Okay, so AI can write queries, but managing the database itself, I don't know. I used to work as a database administrator for, I don't know, IBM, United States server-side operations for about 2 years. And managing a bunch of servers. So, it was a people's job. It takes a person to do that. But if we can have a AI or self-managing or system or something do that, possible. Now they say design new architecture. What will be, there's this design for repair, design for disassembly, design for, it's like manufacturing concept. So this will be designed for what? Self-management, something like that. Okay, well, that's a new word, designed for self-management. Wish I didn't hear anybody anywhere. That's what they're proposing.
Yes.
Self-driving architecture. So there's going to be a new generation of databases that are designed for AI being database administrator. Unless they teach database administrators, teach AI how to do their jobs or make the simpler database structures that AI has easier time doing the jobs. Even people can have then easier jobs if they're self-management databases. So what's the future? What at the end? What do they propose? Any future directions? Usually it's the last chapter paragraph. See, scroll to the end. Before that, results, considerations. Do they propose any future directions? No, they already proposed. It needs like a new related work. So no, they don't have like usually in articles there is like a suggestion for future research or directions, which I don't know might give you ideas if you're IT
In
professional.
terms of like they have some like challenges they discuss about the challenges like the trust gap because it is AI like and their AI make a lot of errors so can be easily be trusted and who will be like the in the power of to explain so there must be the human readable explanation for all the decision, the autonomous decision. So there must be some kind of human readable explanation for all the decision. So these are the challenges they discuss that need to be considered in the future.
Okay. So they still need some sort of a human interaction there on it. Okay. So remember, so you in these articles, when you read, you always want to look what are the challenges in the future, because where there's a challenge, there's opportunity, right? So if there's any challenge and something specifically that you like, have affinity, and can just write the doctoral dissertation on just one challenge, one problem is enough. Hard problem to, and you don't have to even solve it. You have to have some kind of suggestions that makes it less of a challenge, right? So any kind of idea, proposal, framework, or structure, or architecture, any suggestions that might make them less of a challenge or half challenge at least, it's a progress, especially in a business use. How can businesses use, because you're doctor of business at social studies, not necessarily computer science PhD, but social studies in business. All right. That was very, so we got a couple of interesting articles. AI and metadata. And then we got like a classifier for open source classifier for like electronic health records. For now, they're a veterinarian, but they can be expanded to anything once the privacy issues are more clarified in that framework. And we have a new proposals for the new generation of databases, self-driving databases. I never heard of that before. Now I heard like, well, self-driving cars, right? Here in Los Angeles and city of Santa Monica, there are lots of self-driving, those Uber, Waymo, Jaguars. There are Jaguars, self-driving Jaguars, driving for Uber, I would say. But now we have a self-driving databases, self-managing. It's gonna put us database administrators out of a job, but that's all right. That's technology. That's life. Very nice. I hope this was useful to you. Was it any good to you? Reading articles, getting familiar how the articles look like. I mean, you read 5 or 6 of them, you'll have idea of structure, how one article looks like, and what should you write. You know, if you're doctoral students, you need to write PhD dissertation one day. I'll give you some kind of sense. Not that hard, huh? All right. Let me share my screen for attendance. So I want to make sure, and I got these articles. I'll post it back. So where did the attendance thing go? Okay, so let me sort by first name and till I get everybody here. I go by just by the breakout rooms names, so that's the easiest thing for me.
Professor, my name is Raj Thakur, and it's like.
Okay, hold on. I don't see who's speaking.
It's Raj Thakur. Yeah.
You're here. Did you come in late, half class, or you just dropped in and out?
I came late, so yeah.
Okay, let's put you late. No, this is just in here. All right.
Will it be marked as present or like attended or no?
Yeah, that's present. Yeah, that's
Okay.
present. Okay, so you got everybody else in here. Just chill to quick check. Okay, I will then save it. Let me save and show. And if by any chance you're late and you're stuck on road or job or work or family, just send me email, okay? What happened and why, and then I think then I have freedom to change this late to present. I would say, my guess. I just want you all get all the credits that you can and need to complete. Okay, so let's see. Did we talk about assignment? We did at the very beginning, usually clock at the end, but oh, okay. All right. Transition from the let me close the chat. From a work on site to work remotely and challenges with it, and just pick up one industry and then see how they convert it. What did they do well? What did they do? Issues that were on the way, and let's say you were the boss, you doctor of business, and you are suddenly chief technical officer, chief information systems officer of, I don't know, large organization like Disney or Exxon or Chevron or Apple or something. So what are the things that you need to think of? And that's about it. Remember references, 3 references, at least your course book 1 and 2 peer reviewed or more. Right, I'll stop share. All right. So how was this class for you? Learn anything? Yeah, I did. You know, you can be professors. I can be paid tuition, I guess. Thank you for teaching me. Especially these self-driving databases. Wow, I worked as a database programmer. I work as a front-end programmer. Then I figure, database programmers don't. What did I do?
We can hear you.
My screen suddenly went dark, and I thought I kicked it. You can hear me. Okay, I'm not muted. My screen went dark and started showing down. Like, what did I do? Did I kick with my foot or what? My power switch. And I thought that database programmers make more money. So I said, I'm going to learn how to be database programmer. It was in 1997. So I went to work in far away in Irvine, lost 1 hour drive away in one company as a database programmer. 6 months I was commuting. But now it's like 30 years later, we are all obsolete. All computer programmers, one way or sooner or later, one or the other. Either new architectures coming here. So I guess keep going to school. With doctorate, you have some kind of chance to implement a job. I would say. Just a little encouragement. It's not easy. If it's easy, everybody walking down the street with doctorate in something, right? So who said it's supposed to be easy? Right? I know. I see a face nodding, right? That's okay. It took me 5 years or more. They mentioned once they kicked me out when I was doing literature review. They kicked me out of university. They put me on probation because it's 50 reference. When I'm going to read all this metadata thing is actually might be useful. I read one, there's like a 2 months go by, there's literature review A, literature review part B, literature review C. I'm rolling the same course. Literature review D, and I think I can roll 4 times the literature review. And the fifth, I put them on probation. Like, hey, you can't be doing it. You're doing or not doing. So, yeah, no, don't kick me out. I have tension. I already done 3 years of 10 courses. I finished to do something. So, took me about 1 year to do literature review, like 5 times 2 months or something. So you do to count. Okay. Just keep going. I hope this will be useful to get you more familiar with reading articles, format, and what kind of things people write about, what kind of research they do. And doesn't have to be, that's enough. All right. Okay, so it's about 8:50ish, and then it's almost midnight somewhere on East Coast. So we did a very short break or no break, so we are entitled. My boss ever watches this video, right? So, and they will. My other course, they're auditing my class. So, but if they want to do this one, we are legal to end up class early and have a full-time break. You have any questions? I'll stay a few more minutes, and otherwise, feel free to sign off. I'll see you next week, and just do your assignments.
Thank you, Professor.
Thank you, Professor.
No, I'm Professor.
Thank you.
Thank you.
Night.
Night. Thank you for being in the class and helping me tonight with the student in class, Dr. Sugar.
My pleasure, Professor. See you next week.
Thank you. Have a good night.